In this video, I will be discussing how to solve for the volume of a solid revolving around a given axis. To do this, there are three methods you can use, technically two as one is an extension of the other. But before elaborating on them, take notice of the general steps for calculating volume. Always graph the functions first so you can see what is happening. Then, based on the information given, usually the boundaries, but if not, you can find intersections as I'll show later. Shade the area you'll be solving for. Then you can proceed to draw the base, which is simply the cross-section of that function. The cross-section may or may not be a solid geometric shape, but if it isn't and it's rotating around a particular axis, you can use the disk, washer, or shell methods. Use the disk method when you are given one function and washer when given two, bounded from x equal a to x equal b. These methods are useful for when the function is rotated along the x/horizontal axis. The shell method is useful for when your function is rotating around the y/vertical axis. These three methods have their own area formulas respectively, as you can see on the slide. After deciding this, you can then proceed to determine the area set up the integral for volume, then solve. So we're going to try one together. The area bounded by y equals x over 3 equals y square root of x is rotated around the line x equals -2. So right off the bat, you should have taken notice of the line these graphs are rotating around, x equals -2. Because this is on the horizontal axis, we already know that we're going to use the shell method. This will make life much easier. So I took the liberty of graphing the functions. Here is, let me get a pen. Sorry, might be that color. Okay. Here is the line that my function is going to be rotating around. X equals -2. Now I am going to draw the cross section and label it. This is R. This is I think that remembering what r or radius is for each problem can get kind of tricky. Just remember that it is always relating to the line of rotation. If the function is rotated along the actual x or y axis, then you can plug the functions directly into r. If the axis has moved, like in this problem, you will need to add or subtract it from your functions. So in this case, the shaded region, which is right here, while the gap right here is -2. So we're just going to write that x minus -2. And that equals x plus 2. This is going to be our value. For height, you're going to plug the functions in directly. So remember that you're going to subtract the top function from the bottom function, or in this case, the outer function from the inner function. And that is the top, bottom, square root of x minus x over 3. So we already know from the previous slide that our shell method formula for area is area equals 2 pi r times h. So we can actually plug everything into this formula. However, we're not really ready to do this because we don't have the boundaries. Remember I said it has to be bounded from x equals a to x equals b. But you can easily do this in your calculator by finding the intersections, as I have already done right here. It's 0 and 9. So I normally like to go on and plug be very methodical and plug in into the area formula, then plug into volume, but to save on time, I'm going to go on and plug in directly to the volume formula. So the integral between 0 and 9, 2 pi x plus 2 square root of x minus x over 3 dx. And once you plug that into the calculator, you should get 158.336. Yay! So now you're going to try one on your own. You can pause this video and take your time and solve it. So now that you're back, hopefully you use the disk method because it's rotating around the x-axis, and your answer should be 20.106. So I have a mind map for you guys. I think it accurately summarizes everything in this video. You probably won't need this section on the AP exam, but I think it's helpful just in case, like, for practice. You'll likely find this topic in a chapter on definite integrals, but it also draws on concepts from the fundamental theorem of calculus. That's what you saw with the top function minus the bottom function, or the upper limit minus the lower limit. Overall, the best thing to do is just pay attention to the axis of rotation, because that's going to determine which method you use. Hope you enjoyed the video.